So if you have a question, just go ahead and raise your hand, or even blurt it out, I'm fine with that. But let's just try to do one at a time. I've noticed in this room that if two people get talking, even if there's a side conversation, Joe was good for that, having a side conversation, it gets really hard for everyone to hear. So if you have one, feel free to go into the, there's another room over there, that's cool. If this is not exciting for you, that's fine. But let's just try to keep it right here so people can hear. We try to do the surrounding tables, or chairs rather, to keep that to a minimum. So again, thanks for coming. And my name is Chris, KD8MTT. I'm a solar nerd. And I'm going to walk around a little bit, okay? But the focus probably should be here, because that's where what's exciting to look at is. I have quite a number of pictures, and it's kind of how I do a slideshow. So hopefully it doesn't bother people when I walk around or go behind them. This is not too much. But I sort of look at it as I go. So this was just sort of a neat picture of solar. I have a whole bunch of solar stuff at my house, and sort of the way it started was about, 6 years ago probably. I had to negotiate with my wife, and I wanted to get the 30% solar tax rebate. Okay, the federal government will pay for 30% of a qualifying solar system. But there are some little tricks to get the maximum bang from Uncle Sam out of the deal, which really translates to you can't spend 50 bucks. You've got to spend, you can get into it for about $1,500. $5 grand, you can do something really cool. And then you get about $2,000 back from the feds, and that's cash. It's not a discount, it's like, here's 2,000 bucks. Well, that's kind of neat, especially if you can get something for it and experiment. So I went through probably 4 or 5 different iterations of, okay, this is what I think I can get when I look at the documentation. The oil company says it doesn't make any sense, it won't work. Friends say, oh, it just doesn't make sense and doesn't work. Well, if you know me, you won't convince me unless it's proven. So that's sort of how I am. So I got the $1,500 system to start with. It worked pretty good. And so I used the math on my $1,500 system, 375 watts. Well, what if I went, what's my next step? So I moved up from there. And then I was even happier then. That was about the $5,000 to $6,000 mark. But I was really excited because that was cool. I could do some stuff with that system. That system ran my refrigerator and my TV for most of the year. It actually saved me some money. And it gave me emergency power. And it was neat. So then the craziness really took off. And I'll kind of show you that. But here's there's really 3 to 4 different types of systems, okay? The first system we'll talk about is called an off-grid system. And that would be excellent if you had a cabin or somewhere in an austere environment where it was not convenient to run electricity. The beauty of that is that, you already save some money. Also, you can have an off-grid system in your house separate from your on-grid system. All right? The next and the cheapest really is called grid tie. And that's awesome because you throw up a panel and a special inverter and you plug it in. You can even plug it into a wall outlet. I wouldn't go that route, but it's possible. And it will backfeed your home. It won't generate its own sine wave, so it can't electrify the guy working on the line when the power goes out. But the downside of that is that you have no power if the grid has no power. But it's cheap, somewhat modular, meaning you can expand it. But again, for e-com or if you're crazy like I am, that would not be terribly exciting. Okay, now we get into the next two, grid tie with battery backup or hybrid. That's what I have now at my house, okay? They're arguably synonymous in that grid tie with battery backup is what I would recommend for most people, which means that your house runs on the grid all the time and it backfeeds into the grid all the time, but when the power goes out, you have some circuits that are always powered, like your refrigerator. And a hybrid system is arguably the same thing. And you can sort of see up there you got solar panels, then you got a combiner box, then you've got an inverter, then you've got a main, and it sort of goes through the house, and like that. Any questions at this point? Go ahead.
You said it doesn't feed like surplus back into the grid.
It doesn't, it will. The answer, if you're talking about the grid tie system, there's a couple ways you can do it, all right? I would not recommend you set up grid cells. You can, but it's not worth the trouble unless you're putting in a big system. I would do it, except it's a pain in my butt at this point, the way I designed the system. And Cherryland Electric, I can't use any of my slang since we have too many visitors here. Cherryland Electric is not terribly receptive to power, so in order to move my main, they want $3 grand. Okay, fine. However, if I would have put my stuff where maybe I should have, I wouldn't have had the problem. So I don't do cell back. But the way the grid tie cheapest option goes, those inverters match the sine wave coming from the utility and they feed back. So say for instance you have 1,000 watts of panels, but you're at work. Well, you got a refrigerator running and you got the deep freeze running, but that's not 1,000 watts. You're giving it free to Cherryland Electric.
So how does that prevent the feedback to a line that's dead to protect the guy working on the line?
Excellent question. With a grid tie only system, though that inverter is not capable of generating a sine wave. It can only match the sine wave already produced. So the term automatic disconnect isn't really relevant because it's not independently able to generate that power and send it. It can only match it and feed it. So again, for a small system, I have a buddy who works at a bank, and he wants to use a system similar to this for an APC. He doesn't really care about the solar. He really wants the generator upgrade and the battery bank hooked together. Because you know you have your little APC, well, that's not good enough for a real IT situation. And at a bank, they're not really interested in hearing about any little glitches in service. So he's interested in doing this with that. Now, he could add some solar to it, but it would work solely in that situation as an APC. But if they did put solar on it, they could backfeed all the time. And they use so much electricity, they will never be in a position where they're wasting their electricity to the grid. Meaning they use thousands of dollars worth of an electricity a month, so the fact that they produce a couple $100 worth, it'll only reduce their bill a little bit. Does that answer your question? Any more questions? So this is sort of the, I can tell right now that this is an off-grid system. This one's kind of fairly significant. You've got your solar panels, okay, they're your friend. They're actually not a horrific price. You get good solar panels. By good, I mean UL listed, made in the United States with a 25-year warranty, delivered to your house for less than $1 a watt. Okay? So when we look at the system, solar panels are kind of cool, okay? I don't really mind spending money on solar panels. You'll see that soon, but it's a pretty good value. They literally have a 25-year warranty. There's no moving parts. The solar panel itself could care less if it was making full amperes or zero. It does not care. Same amount of wear and tear. The next item is a charge controller. A charge controller is only relevant on a battery system or an off-grid system. It's that little black box there. I have one of those that I really recommend, but what that does is it takes the power from the solar panels and it reconstitutes it to the appropriate voltage for your battery bank. Your battery bank you want as high as you can get it. Mine's 48 volts. We understand electricity for the most of us well enough to know that if you need to generate 5,000 watts at 12 volts, you need a copper wire about the size of my arm to do it. So you can really see the advantage in going up to, say, a 48 volt system. We're going to talk a little bit more about charge rates later that is an additional benefit for the larger, just real quickly, on a 12 volt battery, full charge is 12.8. Halfway dead is 12 even, only when you're not charging or discharging. So that's 0.8 volts determines if you should be using it or not. Well, with a 48 volt system, you take that 0.8 and you multiply it by 4. It gives you a larger range, which will help your charge controller send the appropriate amount of voltage to your batteries at the right time. Most charge controllers, if they're any good, they'll go ahead and they'll do a bulk charge, which means they'll send it everything. They'll do an absorb phase and then a float phase. And that way it gets your batteries fully charged. And they're pretty smart. They have temperature compensation on them. They work pretty good. And they even have the ability to do something called an absorb charge. Periodically you overcharge the battery a little bit to mix it up. So then you have batteries. We're going to get more into batteries later, and believe it or not, I have some opinions on what kind of batteries you should use. You need a bunch of them. They're the Achilles heel of any solar system. That's the part that we really like to have advanced. Next you have an inverter. An inverter is sort of the blue box there, and that inverter, I can tell by the look of the diagram, is capable of providing AC power for your home. That's you, the user, and the light bulb. But if for some reason your solar panels didn't quite do enough, you can run your generator. The nifty thing on a system like this, how many of you have generator systems at home? Decent sized ones? Good. Okay, so you know what happens when I say, in Snowmageddon about 3 or 4 years ago, I was out power for 10 days. 10 days. Anybody tell me what that means for the refrigerator, the deep freeze, and the marital status? They've all been stressed, because if you don't run that generator nonstop, your refrigerator's gone. I had a little tiny generator, and I attached it to the house in a safe manner, and made sure it was disconnected from the grid. And my plan was I'm going to run that generator, which I already amp tested. I knew it could run my refrigerator, my deep freeze, and my well pump all at the same time. All right? So I figured I'm going to run that a couple hours in the morning, take a shower, do the dishes, cool down the refrigerator, make some coffee, and we'll do the same thing at night. That worked just great, except for it was exactly like opening the door of the refrigerator and leaving it open. It absolutely 100% did not work. Your refrigerator needs to be powered all the time, or you can just eat all the steaks. So, but this system, for instance, at my house, I have a big battery bank. So when you fire up the generator, the first thing any inverter will do that's worth its salt, the first thing it'll do is it'll say, hey, you're sending power to me through another avenue. Let me check this out. So the inverter will study that electricity and they'll make sure it's clean. Okay? I have a chintzy generator and a nice generator. The chintzy generator is still apparently good enough to get through. Okay? But it looks at the sine wave. I don't believe it'll accept modified. The generators don't produce it. So it'll make sure it's reasonably clear you've got both legs. It'll say, okay, we're good with that. Well, that's great because the generator's warming up right now. Then it'll match the sine waves. So that the inverter sine wave and the generator sine wave are now in sync. And then without a blink of a light, it'll switch to generator. All your house loads just go to generator. And then usually after 2 minutes, it'll start charging the Hades out of the batteries by like 5,000 watts. Because you also know your generator uses almost as much fuel, 70%, at idle with no load, as it does when you're running at full bore. And if you want to flush the toilet at 3 o'clock in the morning, and if you want to have ice cream that's still ice cream, you're going to leave the generator running. Generators run a couple gallons an hour. 2 gallons an hour, 24 hours a day, 10 days. Sound good? No. So, but what I was able to do with my house, we ran 10 to 12 kilowatt hours per day before we had any solar crap. Okay? That's pretty modest, okay? But it's reasonable. We have a deep freeze, we have a refrigerator, we have all the modern stuff, we have a toilet that flushes, and we have real lights and stuff. So, what I was able to do to run my 10 kW generator for 2 hours a day, 4 gallons of fuel, run the house for 24 hours. Because it ran off the batteries. Charge up, run down, charge up, run down. So that's a cool option. And You can size the generator smaller, you can do a lot of options. I have one buddy who has got quite a bit of money, I really like him, I won't give his name, but he spent 18 grand on the generator backup system. Well, he could have got a lot smaller generator. Now that one ran on natural gas or propane, I'm not sure, but he didn't want to mess with nothing, right? Okay, you got a little bit of messing with stuff here, but, and he wasn't that concerned with the cost of running it. But you could, a more regular person could say, gosh, I'm spending all this money on a generator, I know it's going to be very expensive. You could consider a smaller generator and a system like this. Just a consideration. Questions? And this is just another diagram. You got the solar panels, you've got a combiner box here, charge controller. There they split the DC disconnect, and now it feeds into your house. Here what they're doing is you've got AC that feeds your house all the time, but if the power goes out from the utility, then only this section will come alive, okay? So that would be grid tie with battery backup. That's kind of that's kind of the best system. You can do everything. The system, the hybrid system I have, I can do off-grid, I can do on-grid, or I can do grid tie with battery backup. It costs a little more to have that option, but you can do everything. And it gives you a lot more options. That is an example of, this would be system number 3. We're at revision 5 or 6, okay? So here on this side, right here, it's a lightning arrestor, and that's a combiner box. So the solar panels all feed into the combiner box. They go into these 2 chargers. They come through this disconnect. They charge the batteries. Power feeds out of the batteries through that huge breaker into that inverter. That inverter feeds the house. The generator kicks on, should it be needed. That's kind of the system there. I have a cover that I put over that in the winter because that's in a barn outside of my house, and that was really adequate for the most part to run the house for a pretty solid 9 months out of the year. About halfway through December to about halfway through February, in northern Michigan, you're either not going to use any electricity to speak of, or you're not going to be on solar. You might be on generator, but you're just not going to produce enough, from my experience. And when you see the solar array, you can say, oh, well, then he must be right. Here is grid tie. Grid tie is a little simpler because you got the solar panel, and you got the grid tie inverter, and it goes to the house. No battery, no charge controller. Pretty quick, pretty easy. What's the disadvantage of this system?
No batteries, powers out and slide down.
Exactly. Power's out and you ain't got no juice. He's 100% right. This is great as long as the power's on. And it'll save you some money, and you can feel good about hugging trees and stuff, and that's cool if that's your thing. I like trees, and I wanted this extravagant hobby, unlike many other hobbies like power boats, motorcycles, airplanes, guns maybe. I wanted this one to give something back to rationalize paying for it. So the federal government helps some, and actually Cherryland Electric helps some too. They started a new program since I got started, big shocker, and they give you a little money too. They're forced to, but they do, so win-win. Panels. Any more questions?
Would Riverside Light and Power give back some money? What is their policy?
I'm not a spokesman for them, and I have Cherryland, but my understanding is they are way more receptive.
Okay.
At one time, they were committing to buy power at a much higher rate than they sell it for to make their structural organization, and they were signing contracts to do that. Had I had been in that place, I would have emptied my retirement fund, and I would have a big array. When you see what I have now, you'll say, don't you already? And I would say, no.
Is that 30% tax credit still in effect?
It is.
You know how much longer?
It's scheduled to be over at the end of next year. And so I don't know if it's gonna, we're gonna have a different president, right? So, and they're likely to be less friendly. However, it does give us energy independence, yada, yada, I don't know. So we'll see if that's extended. I don't know. Did that answer your question?
Yeah.
Okay, other questions? All right, we'll keep going. Panels, you got a couple sizes. You got 2 foot by 4 foot, which you don't see much of anymore, because they're not efficient size. They're handy to carry. They're great to put on your camper, but the watts to dollar ratio and efficiency rating isn't quite as good. So most panels are 3 foot by 5 foot. And in reality, they're a little bigger than 3 foot and a little bit bigger than 5 foot. And they weigh about 50 pounds apiece. Now they're pretty frigging sturdy, okay? But they're kind of awkward. So one should know that. It's not fun to carry one up a ladder. There are Solar World panels, which is what I suggest, made in the United States, 25-year warranty, UL listed. I'm not going to suggest anything that's not UL listed. There's too much electricity, too much energy for us to be dealing with Chinese junk. I've got a Bale Plum radio. Okay, got nothing against it. I'm not putting 100 amps through it. Things can start on fire. Also, it's not cost effective for panels anyway to get Chinese panels. Big deal, so you get Chinese panels at 70 cents a watt. Feel good about that? I didn't. I didn't feel good at all, not when I can spend $1 a watt and get arguably the best in the world. Made in the United States, UL listed, delivered to my house. You can't buy one. You gotta buy more than one. But you're gonna run into that with Chinese panels too. That's one little glitch on panels. But, so, you got 2 sizes. Voltage, most panels now are in the 30 volt region, okay? And it's just by the nature of the way they lay out the cells on the size of the panel. If you have a good solar charge controller, you don't care. There's my charge controllers will take up to 150 volts DC, and they have them now that do 600 volts DC. It's kind of nice for line loss and wire size, right? You can link panels together, it's just like batteries, one to the next, to the next, to the next, and you have 2 wires coming out of your array. That's pretty cool. So most 3x5 panels are 30 volts-ish, 35, 36 volts. You size your combiner box to match the strings of panels, which is simply how many panels are you going to hook together like batteries in a row, become a string, and then they go to a fuse, and they go to a combiner box, and out of the combiner box you run a nice big fat wire. One. We with me? We good? Monocrystalline and polycrystalline. Monocrystalline is better. Monocrystalline is wasteful. Monocrystalline costs more. Monocrystalline doesn't give you much more. The way they make the crystal, okay, I'm not going to spend a huge amount of time, but they make a round crystal and they slice it. It's round, so it's denser, it produces more power, and it's grown in a different environment. Polycrystalline are grown on flat plates. They're square. So when they cut it, they don't have any waste. I love polycrystalline. I'd pay a little more for monocrystalline. If I was outfitting the space shuttle, I'd want monocrystalline. If I was only going to get 5 panels for the top of my motorhome, I might get monocrystalline. But I'd probably rather just get 1 more polycrystalline and have way more power and spend the same money. So that limited difference there, I wouldn't get wound up on it. The back of a panel looks kind of like this, and I'm going to send around a couple little gadgets. These are called MC4 connectors. If you push them all together, they'll lock, and I'll send a tool around for you to unlock it. Or you can use vice grips, or you can pull really, really hard and swear some. All of which work. But those are on the ends of each panel for the most part has about a 4 or 5 foot cord on it. One's positive, one's negative, and they just clip together. And on the back of the solar panel, you've got a little bit of data here, your maximum volts, your maximum amps, etc. And when you size your charge controller or the amps in your combiner box, you look at that. But it's not complicated. You know, if you've got a 5 amp panel and you're putting 3 of them together, you get a 15 amp breaker, DC rated. These are made to go inside a combiner box. They're called DIN rail. They're nothing super fancy, but it's a DC rated breaker, which is a little different. Again, Solar World, I saw a video where they drove a diesel pickup truck onto 4 panels. Installers regularly walk on them when they put them on. I do not. But the point is they're pretty sturdy, okay? A shot from an air rifle is gonna be a detriment. But they're pretty sturdy for most stuff. Solar World has done a tremendous amount of testing. They've got a lot of videos showing you awful things they do to their stuff and testing regimens. They also overrate their panels. So they've got a performance guarantee as well as a manufacturing guarantee. When I spend good money on something, I pick up the phone and I ask them questions. And if they won't answer your questions intelligently before you handed them money, they absolutely will not do that after you handed them money. I was able to talk to people that knew about solar panels when I called the 1-800 number. I didn't have to press 9 things, talk to 13 people and 5 salesmen. No, I could talk to a person that actually knew about the product. So that's one of the things that I do when I spend good money on a product. Maybe not when I buy a fine radio, but when I buy solar panels, I make a phone call. Questions on panels?
What wears them out? Heat?
As far as I know, nothing. However, they do have panels running. They do seem to lose some of their power over time. That is to say, some 25-year 30 panels are at their 87% production rates. So I suspect that they are subject to some level of UV degradation. I don't know is the straight up answer, but I know they last a heck of a long time.
They have an operating temperature specification, operating range?
They do, and Solar World far exceeds. Their testing went to -50 and positive 170 degrees. So they did a lot of testing in the desert and so forth. The companies that aren't Solar World, as long as they're not Chinese panels, and again, I just don't see the use. Sharp makes some good panels. They seem a little cheaper. You're looking at 80 cents. But I've got a whole gaggle of Solar World, and they all do what they say and say what they do, and you can come see them. You can come see all of this. I'll leave my card. I'll talk to anybody on the phone. I'll answer emails a little bit because I hate emails. I will not appreciate a text message no matter what. And I will irritate Toby on the repeater to no end if you want to talk about solar. All benefits, free to you. I'll show you what to do. Did it all myself. Go ahead, Jennifer.
Why don't we schedule a picnic or something?
We can do that. I would prefer that if you guys want to come to my house, which you can. I live in Interlaken, in between Interlaken and Honor. Let me know. We'll make an appointment. You can come out and you can see it all. I'll show you how I did everything. Chances are you all know how to do all this, okay? It's not that complicated. Don't be scared.
Over the course of the year, what do you average hours per day approximately of production?
Well, it does depend dramatically on the time of year. Today, I got 25 kilowatt hours. That's a lot. That's more than 2.5 times what I use in a normal day. The charge controllers I have are from Midnight Solar, again made in the United States, UL listed, and the service tech guy I talked to is a ham radio operator. His name's Ryan. You can't talk to him anymore because he's too important. But the other guys are pretty good. Their controllers report to the internet if you collect it, and I can show you and give you my password. You can look at the actual production of each controller array over the last 5 years, and you can look for yourself. There are a couple hang-ups with an off-grid system like I have. All right, in the summertime, I can produce way more power than I could ever use. Well, I bought 2 air conditioners. I bought an electric heater. I bought a bunch of electric crap. We have a little electric stove now, because in the summer I got power coming out my ears. And I'll be gosh darn if I want to pay for propane when I can use this for free. But I still can't use it all. So it doesn't tell you what I could make. But you can see, and you'll see January,
Well, what's the maximum load for appliances that solar system can handle?
My solar system?
Yeah, the maximum.
I have two controllers, both rated at 6,800 watts continuously, so I can flow 14,000. But if you use Schneider Electronics XW, they're rated and perform at double production for 5 minutes. 28,000 watts for 5 minutes. And okay, for anybody that's got a generator and a meter, they liars, okay? That's a Generex XG series, that's a commercial grade, cost me some money, the only one to get. It's not that much more, don't go to Home Depot, get the XG, made in the US, UL listed, doesn't cost that much more. A good generator, it's a 10,000E, that will not sustain 10,000 watts, even though it's supposed to do 12.5 surge, 10,000 no way. 9 on a good day with a fan. But my Xantrex controllers, the first one I had was a 6,000 watter. I ran it above 6,000 watts for 10 hours a day for months. So unlike the generators, they don't lie, or I don't know, some other reason they don't do what they say.
How many watts were you doing on those dark days we had?
It depends on the day. Today wasn't that great, and it also, the angle of the sun makes a huge difference. Also, the angle your panels make in relationship to that makes some difference. Some of my racks adjust angles and some don't. So on a 5,000 watt array, you know, on a bad day, would I get 2 kilowatt hours? Sure. But even in the summer, in a rainstorm, you'll still be producing power. That's a little bit of a mind bender. So, way worse, I have exceeded the rated maximum of my panels before, which is something you never hear about people that don't have solar world panels. They say, oh, well, yeah, but you never get it. Well, I have. You can see the records. I produced more than 5,000 watts in each array before. The problem that I have is I can't use all that power. Because I've already got the refrigerator running, I've already got the 2 AC units running, and you know, you can only, the batteries are charged up, what can you do? More questions?
Are the poly crystalline ones always blue and the mono is always black? So you're just looking at them, you can tell what's left?
Pretty much, and the other thing is, these are typically monos, because they got those little squares. Because they're circle, the wafers are kind of circular, because they had to cut them out of a circle block. So black and the little diamonds, probably mono. Kind of bluish, not little diamonds, probably poly. More questions? Lots of them. We'll start here, we'll go this way, we'll go across.
Okay.
What is Solar World the manufacturer and direct retail?
I've never been able to buy directly from them. What I would do is there's a whole bunch of online companies, I make a supply list and I make them bid. That's how I know.
Okay, how much of your array will power your ham radio station?
Oh, so little it doesn't even count.
Okay.
Way back when I had my first $1,500 or less setup, that was one of, my first solar presentation was don't buy a power supply for 200 bucks, buy 2 batteries and a charge tender. And I still think it's a great idea, except now they have switching power supplies so cheap it makes it hard for me to make the argument. But back then, you got an Astron BS35 for 300 bucks. 300 bucks, you can get 2 6-volt T105 golf cart batteries and a really good charger that will not put hum into HF. And then you can use that for all your radios and you can run for like forever. I got rid of all my power supplies, I don't have them anymore. I use batteries. But of course my whole house is batteries, so. Is that good?
Yeah.
All right, let's see.
What's the optimal angle for the solar panels to the sun that you want?
It changes by season and latitude. For here, summer angle best is 21 to 23, winter is almost 60, fall and spring 45. Simple math is take your, latitude plus 5 degrees. We're at 45 degrees-ish, so 50 would be your, if you're gonna have one angle, that's it. Snow likes to come off solar panels that are steeper rather than flatter. But you don't get jack deadly for power production in the winter, so do you really want to go to a lot of trouble? I have three different angles you're going to see because I'm not sure I know the answer to that yet.
about battery longevity?
Well, I have opinions on all things, including batteries. What I like about T105 golf cart batteries is traditional old-fashioned lead acid, which means they're heavy. It also means you're gonna have to top them periodically. I'm a nerd and I don't care. I like screwing with this stuff. I always go out there and look at my junk, so I don't care. If you're in an austere environment where you weren't gonna be able to top the batteries every 3 months, I would say, okay, now you gotta have gel. Or absorbed glass mat would be a better alternative. More money, less bang for the buck. T105 golf cart batteries life is 6 to 15 years. That's pretty good. They're also, you know, the best price point, the most common, and you can huck one. 2 if you want to bad enough, but 1, you know, for sure. Good?
That's my question.
Okay, Hope, what did you have?
How much do they cost?
1, depends how many you buy, depends how many you get, yada, 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 around $100 for 1 battery. So, back to the power supply deal, 2 of those, $200, and a $50 charger. You gotta have a $50 charger, or you're gonna put home in your HF radio. So if you're a tech, you won't care, but eventually you'll grow up, become a general, and you'll be like, why is my noise floor like S2? That's fine. But anyway, a charge tender's not too bad, they're about $59. So that, and I had that in my house, and that's what I did. I put them in a little box, my wife made me vent it, which I don't think you need to do, but that's what I started with. And then you can add a panel to that. I would not recommend you go to Menards and spend $69 on a 35-watt panel, however. Don't do that. I got one, remember watts to, you know, thing, and Coleman is even released from HoChiMin.com. They're gonna be the crappiest plastic junk. It'll work, but I'd much rather try to get you to get a big boy panel, if you will, when somebody else orders some. The last time I ordered panels, Charlie Kiesel got 9, another guy got 3, and it's a great time to say, I'm not as crazy as you, Chris, but how much can I have 1 panel for? And I'll say, well, these are 260 watts, so $260. Well, you got a panel. Go ahead, Jennifer.
What do you do about snow?
Well, you can allow God to sweep your panel for you, but it's gonna take some time. You're gonna use solar energy to keep the panel and get it to slide off. Gravity will help you, but you can either get out there with your little broom and sweep them off like I do, because I'm crazy and it's good exercise and the dog's gotta go out anyway. Or you can wait for the sun to do it. Or you can say, we don't get any friggin' electricity in the wintertime anyway, and for that 3 months, you don't worry about it. So, or the greater your angle, the faster they clear. There's a difference between 45 and 55 degrees. Go ahead.
You're talking about, the question about panel angle. Are your arrays set so they're adjustable per season or not?
Roughly half of them, I can change the angle. None of mine are on trackers. Trackers are awesome. This cheapest tracker I can find holds 8 panels and it's about $2,200. And what that means is it's like a flower, right? It'll just track that sun beautiful, and you might get 15 to 20% more power out of it. But that just costs you like $2,500, and I need a bunch of them, and stuff wears out and breaks, and why don't you just buy some more panels? That was what I did. So I went with more panels. So some are adjustable. I've got a barn at 45-degree angle, or probably 50 degrees. I've got adjustable racks at about 60 degrees, and the solar trailer you'll see at 45 degrees. And I can tell the difference, and I can see the snow shedding difference. So, kind of depends. If you're gonna build a rack, you've got some choices. If you've got a good steep pitch, 45 degrees due south on your roof, I'd be like, do that, because that's all ready to go. If you're gonna build racks, now you got some choices.
Batteries, are you hooking those up in parallel or series or?
Both, 6 volt, in a string, 8 to 48, bus bar, 4 rows. With me?
Yeah.
Pooch? Oh, next guy, coming this way, sorry.
Do you, 2 questions. Do you monitor the temperature in the panel, and is the power production efficiency affected by temperature?
Yes, and kind of. No, I don't monitor the temperature of the panels. However, the colder it is, the higher voltage you get. And it's one of the calculations that you have to briefly do with your charge controller, because when it gets really cold and really sunny, for one reason or another, there's way more voltage. So your charge controller, if normally you're sending 120 watts in, but you get VOC, it's called, and it drives you to 190, and your charge controller is rated to 150, this is probably too far. That'd be a problem. So hopefully it has a shut-off, but better you design the system to accommodate that increase in voltage. Do you have one more?
Any RFIs in the charge controller?
I don't know for sure. I never take my system is far enough from the house I can't tell. I will say that when I did run the house, I ran inverter to power supply, I got nothing. When you go out to the solar barn with a fire service pager, it will sometimes break the squelch. There's a lot of magnetic field there. So I don't think it would be such a great idea to run an HF radio there. However, I think that, like on a field day, I had a small, that $1,500 array, 375 watts, those are Taiwan panels. Anyway, I had those at field day and was running them, and there was no disturbance to anybody, but we weren't, right next to it. And I have runoff those, so I think there's some, but I think with a little reasonable distance, you're good. More questions?
What did you do to, if they're all connected together physically, and there's really high speed wind, that could be terrible. So how did you do yours to protect against high winds?
You mean the panels themselves?
Panels.
Well, the panels are rated for like 180 miles an hour, so good luck with that. However, whatever you mounted the panels on may not be. So in my case, I use wooden racks, which will all say, oh, don't do that, use metal. Well, wait till you buy metal and you'll see why treated lumber and a lot of it looks like a pretty good idea. I'm also handy and cheap, so there we go. So you can build a barn with a metal roof on it, because all guys want an extra barn, and you can cover it with panels. And you're gonna see a couple of them. That's a good way to go, and then you get a free barn, kind of free. So, in no jest, you have to make sure if you put it on the roof of your house is good. That style construction would be adequate for wind loading. You do have to think about it. And when you look at the one barn, you'll be like, wow, that is quite a sale. So, more questions?
When you got to $5 or $6 grand, how many watts were you at?
$5 or $6 grand will get you about 2,500. What I would recommend, you would get 2,500 watts worth of power. You'd get a big boy charge controller, and you would probably get a big boy inverter and 8 batteries at the $6,000-ish. But it's going to turn into 4 after April 15th. And Cherryland Electric will give you about 180 bucks, just as a Merry Christmas. Here's 200 bucks.
And then, is anybody doing anything still with the low voltage side, or does it all just hit inverters?
If you do what I recommend, there is one inverter that's, here's where the inverters go, and we're going to get into inverters, but I would recommend with real little system, 12 volt, pure sine wave, UL listed inverter, costing you about 400 bucks. That ain't bad. For a 2,000 watt, 12 volt inverter, and that's handy, because you can hook it to your car and run a circular saw at your buddy's house. You can also use it in your solar setup. The next step I go from there is straight into a big boy inverter. That would be with a charger, a generator hookup, pure sine wave, and $3 grand-ish. Strings, some of this we talked about, so I'll move through a little faster, but strings are how many solar panels do you put together in a row. And again, it's a function of voltage. Imagine a solar panel is simply a battery. These batteries are about 30 volts apiece. If you put 3 30-volt batteries together in series, you get 90. you also increase the amps, so you have to keep that in mind. So that's what a string size is, how many panels in a row. You also have to think about cold temperatures raising the voltage, and then how many amps can your wires carry. Most of those, that connector I passed around, that MC4 stuff, that's 10 gauge strand, usually. I think you can get 12, but I always get 10. I don't know where those are at. Where are those at? Did those get all the way around? Everybody get to see those? And the breakers too, did those go all the way around? Good. So there's one, well, half of them made it back to the table, so we can send the other ones, keep those rolling if we can. They're just, DC rated is a little different. When I started, I didn't use all DC rated stuff because it cost more. One of these breakers cost about $15, not too bad. And I can show you how to put the ends on MC connectors, it's really not too big a deal. And you can borrow the $2, holy smokes, how do I undo this? Wow, wasn't that easy with that tool, you can borrow that. All those are options for you. Angles, we've already talked about it some, yes, so some questions I was planning on getting there. Basic, take the latitude, add 5%. Best is to change your angles 3 times a year. 21, 45, 55 for around here. See how that's adjusting? That's sort of the angle. Here's an example of some trackers. That's about a $2,200 tracker right there, encompassing 8 panels. You know, they normally go on a pole, they normally need some cement, so you got more than just a tracker to pay for. Okay, that's my, there are 2 arrays there. So that is 10,000 watts of solar. See the barn behind it? Because you gotta have a barn to put your junk in. That's what I figured. Those articulate. So that right there is in the winter, about 55-degree angle. You can see here where I dug the line in and ran the, that's where all of my energy is produced, about 350 feet from the house. It comes underground to the house. The problem with this scenario with backfeeding to the grid is I need to move my main out there. And to move my main 300 feet, Cherryland says I need to give them $3,000. A little closer look. These are adjustable. They articulate right here, and actually now they're in the 45-degree angle. See how that ratchets up here and then comes down? I think I got a couple more pictures. You can kind of see how they move. Inside of the barn, that's in there. I was thinking about putting canoes or something in there. That was, again, the 375 watts, very beginning. And I just used treated lumber and figured, well, why don't I just drill a couple holes and plop them in there. Then eventually, I put it on that rack, which I took out in the woods, and that rack comes off and goes on the top of my little camper, which is exactly went to field day. There's that again, there's that in front of that. Okay, off-grid, expect to lose 3 months of production is going to dramatically decrease. You can help by getting out there like that. That guy, he probably doesn't have too much problem with snow building up on there, because that is probably a 65-degree angle. So theoretically, they're further up north than us. If you're gonna, I would almost disagree. It depends if you're gonna be on grid or off grid. If you're gonna be on grid, you might want to choose the best angle to get the most power over the full year. If you're gonna be off grid, you probably want to go steeper, because I got more power than I could ever know what to do with in the summer, and not enough in the winter. So why not just make a steeper angle? Combiner box, it's just a place where you can jam these together. They go together just like so, and we'll see a couple pictures. Usually the combiner box holds like 6, sometimes 12, mine holds 6. 6 is good. 6 will link up nicely with a classic 150 charge controller. So that's what I used. You can also go old school, you know, with some wire nuts, but you don't have, then you're like, oh, well, maybe I should, the wire nut's not really a disconnect. And you don't have a fuse. So you can wire in an automotive type fuse. I might have tried that. And that'll work for 3 panels, but when you want to do like 12, you're like, wait a minute. Ah! That's what you wanna do. Those are what I have. I have exactly those. They have 6 breakers apiece. It's an aluminum box. Got the little pluggy doos. You got some bars to attach stuff for. Combines. This is your PV positive here. You can just come off the negative here. And you come out of there with a much larger wire and feed directly into your charge controller from there. Everybody with me? Charge controllers. We got a Ho Chi Minh on the left. Might be fun to play with, never had one. And we've got a cheaper one over here, which is about 150 bucks, a Pro Star. That's respectable. 2 types primarily. You got MPPT and you got PWN. What you need to remember is MPPT is what you want. The way it works is this. Okay, if you're going to use a PWM, a pulse wave modulated, like this little one, you want your battery bank to be almost the same as your voltage. You want to use the little panels, and you want to go 12 volt. Because the charge controller essentially, for those of you that understand this better than me, will just bear with me that I'm simplifying it, they waste the extra electricity. Your batteries only want 13.6 volts. Well, the panels are giving you 14, and we waste the rest as heat. Sound good? No. MPPT, cha-ching, it costs more. But I feed in at 150 volts, and it gives my batteries whatever I want. I decide to go to a 60 volt system, click, click. I decide I want to go to a 12 volt system, click, click. I press 2 buttons, changes. It doesn't care. It'll change it. It also more efficiently loads the panels. And they also generally have some extra little tidbits called AUX load control. The charge controller knows when the panels have more power than they're feeding. They're like, hey, I don't know for sure, but I can tell you, I can get more out of these, but you're not using it, so, oh, you want me to turn on this solid state relay that's connected to an electric hot water heater element that's a pig? Yeah. So then the charge controller turns it on, and I'm able to get some of my energy back. Do I need electric hot water? Well, probably not. But it beats having it go to waste. So you can have AUX load controllers turn stuff on, like an air conditioner, like a dehumidifier in your basement, like a bunch of fans. Like this time of year, electric heat. I run about 7,000 watts of electric heat. Wind stove doesn't have to work near as hard. What else am I going to do with it? That is a small MPP charge controller. Again, we're getting back to my very first system. So we've got, it is UL listed, is made in the United States, and you can call the man who made it. And it goes into my little shutoff box where I got me some meters and some stuff there. I went with manual shutoffs and stuff, and that's what I started with. And that one even has an AUX controller. That's really little. That's a really little PWM charge controller. And I'm not dissatisfied with it. I used it on a field day. It's what I take with that small system. PWM has AUXs that I don't use. I did, but I don't now. Another picture of it. Big boy charge controller, okay? They cost $500 or $600 bucks, and that's a Midnight Classic 150. That'll accommodate around 5,000 watts of power, or one full block of 6 of those. And it'll do everything you're ever going to want it to do. It'll charge your batteries the way you want. It'll report to your Wi-Fi system. It'll post on the internet. It'll make you coffee. Well, it'll make you coffee. But it'll work for you. It's not free. Has a 6-year warranty. They fix them. You can call and talk to a real person. Can't talk to Ryan anymore. He's too important. But he was a ham. Still is. And that's what I use. And you'll see more of them. There's 2. Then here, the power comes from the charge controller and it goes through a big breaker like this guy. This happens to be a 3,000 volt breaker, and I think it's an 80 amp. The reason it's not there anymore is because all my arrays produce more than that. They produce close to 100 amps, so I had to replace it. But a DC rated breaker is different than an AC rated breaker, so when you start to get into big boy, you might as well. And you know, you're looking at 25 bucks. Sorry. Not as cheap as Square D, but, sure.
Chris, you got a lot of time and money invested into this, did you have to talk with your insurance company about this? Did you have to get this inspected? Can you address that aspect a little bit? Or maybe I shouldn't ask that.
Yeah, all these new people here, I don't wanna, how many people do I wanna have to bury on the property? Insurance companies, I don't think it's any of their business, and I did make a claim, because I took a lightning strike. They weren't concerned at all, and it cost them some money. Roommate of mine, master electrician, like a long time ago, which meant I wasn't impressed, I was a, what do you call it, when you haul all the stuff and you do all the work and you drink beer with your buddy?
Apprentice?
Apprentice, exactly. So I was Tom's apprentice, which meant I did learn I can wear a house. But he's still a buddy, and he's certified in solar. So I had him come look at all this stuff. And I'm not that concerned about what code is, however, usually it's a good idea. I want safe, and everything I did was safe, and there are several things I did that exceeded code. Secondly, with solar, like 5 years ago, there was no code. Now there's some, and they're fixing to make more. If you don't connect to the grid and want to do sellback, you don't need an inspection. By don't mean, what I mean is that if you want to do sellback to Cherryland Electric, they want to replace the meter that they recently put on your house with a meter much like they took off your house 2 years ago for $100, and they want an inspection sticker. So that's how that is. But if you don't want to, my opinion is it's a separate system and it's none of their business. Especially if you do the first system I did in the house it was completely separate. I ran 3 outlets in the house in metal conduit that were solar all the time. Completely separate from the grid. I had solar power, battery power all the time on those outlets, and it was a redundant system. I would call it temporary. To me, that would eliminate the need for any inspection. So that's the most honest way I can answer that question.
When you talk about redundant systems, how much redundancy do you have within the system? In other words, if you were off grid and you were really relying on this thing, there you've got what, 2? Okay, so I take it you could take a hit on some of your panels. Batteries, you gotta get on those batteries.
Well, the batteries are in strings, so a battery's pretty sturdy, okay? If your batteries blow up, you need a new barn, okay? That something bad happened there, but batteries usually don't. But if you had I can't really imagine a scenario where your batteries would fail, but they might, but even so, there's 4 strings of batteries in that system, 2 charge controllers and 2 arrays. You can also isolate each string from the solar standpoint, so the neighbor kid gets a Crossman 177 air rifle, and he customizes one of my panels for me. Well, that will shutter that will make one of these not work with beans, because the charge controller will only be able to get the maximum amount of power off the weakest string until you turn the string off. And then only those minor and series strings of 3, so I could turn off those 3 strings, deal with my neighbor, and it would make a minor difference. So solar panels, you're good. Charge controller dies. Okay, you got 2, now you got 1. That's the end of that. Inverter, if you only got 1 inverter, the only good thing I can say about good stuff is, each one of those has a 6-year factory warranty. They've never asked me any questions about how old it was when I called to talk to them or anything. And I've never had a problem. And Xantrex inverters, I was convinced that my 12-volt, $360 inverter wasn't working right. And they said, well, you can send it back and we can look at it. And I'm like, well, why don't you send me a new one? And I'll put this one in that box when it gets here, and I'll send that back to you. Okay. And they did it. And it did the same thing, and it was because you can only do so much with a 12-volt inverter. But nonetheless, you get that type of service. Never had a problem with any of those products. Solar panels, yeah, no. So certainly it's possible, but I think that with quality components, I don't think we have the, some of the problems you do with stuff now. More questions?
So your battery banks are set up for 48 volt,
Yes.
and are the grounds common?
Well, it's a DC system, okay, so you've got, and I do not have my, that's a long conversation. Rather not to ground your DC negative, mine are not. Some people's are. These are actually not only, they'll do ground fault and arc fault. I have them both turned off. Any of you that are electricians know why, because it's a huge pain in the neck. And you can program the delay circuit and stuff, but you know what? Come on, I got breakers, right? So, it's hard for me to answer that question. Common usually talks about a neutral, and they are normally bonded, and you know every system is bonded in one place, in the United States anyway. But this is, the DC, it's just like your car, you got positive and negative. The only difference is in your car, a lot of times you use the frame as a negative source, crappy as it is. It's the same premise. And for the record, you can touch 48 volts all day long and not get a shock. Unless you're in shorts in a puddle of water cleaning the terminals. Wow! Speaking of batteries, lead acid, absorbed glass mat, or gel. Absorbed glass mat is really lead acid, but they sort of put a material in the liquid, in the water, and it makes it so that you don't have to maintenance them very much. It's way different than a maintenance-free battery, which is the same as a disposable battery, okay? If it's a deep cycle battery, it is not 12 volts. If it is a deep cycle battery, it is not 12 volts. That would be a marine battery, or an RV battery, or a magic piece of junk battery. That is not going to perform at all like a deep cycle battery. Difference between a deep cycle battery and a regular battery is thickness of the plates. You can't get that many plates into one battery to get 12 volts. You can only get 6. If you got your big boy pants on, those are called T16s, they're 2 volts. You're talking money. They cost a lot, more than Chris has.
Those are telephone batteries, right?
Yeah. But, interestingly enough, they're making so many T105 forklift golf cart batteries now, they're finding that the T105s rival the T2s in longevity. I like the sound of that. But those are sweet, and you wouldn't have as many, because I got a lot of batteries to water. So, you've got lead acid, which is old technology, which is exactly what I use. The main downside is big and heavy. Cheap, and you gotta fill the battery water. I do mine once every 2 months. And I got a little machine I made to make it way easier with a lot of batteries, but you gotta kinda want to. Now, if you use a battery backup system, like you're doing hybrid with battery backup, you're not using your batteries, you probably won't need to top them. But I use my batteries, so you need to top them. Absorbed glass mat, again, it's really a wet battery, but it's better. But they're quite a bit more expensive. They don't off-gas, you can invert them, they're cool, but they cost more. Gels are great, but both absorbed glass mat and gel big time are really picky, like you overcharge them and now it's garbage. Whereas like the lead acid is pretty forgiving. It'll put up with a bunch of an abuse. Sometimes I screw stuff up. So, that's where we're at. Making sense?
Okay, so the hydrogen sulfide gas that comes out of that.
Yep.
The question I got is, do you ever add anything to the battery to replace the sulfur? Or just distilled water?
Just distilled water, because the hydrogen sulfide gas, which only comes out when the battery is at the high end of its charge point, it's called its off-gas level, and it does, it produces a small amount of hydrogen sulfide gas, which you can smell, by the way, and it doesn't produce much of it, and I'm not worried about it anymore, and I have a whole bunch of batteries. So either I'm ignorant, or it's not that big a deal, one of the two. But I've been playing with them for a long time. Again, off-gas point is usually just above the highest absorbed voltage. Shouldn't be there anyway. remarkably small amount of off-gassing should take place. You do want to consider ventilation for your battery box. That's a good idea. But why don't you need to replace it? The hydrogen sulfide gas is a reaction of the sulfuric acid in the battery with the water getting hot, becoming excited. What comes off is the vapor, the water. So we only need to replace, under normal circumstances, the water that evaporates rather than the acid itself. A good question, I wondered that myself. Don't I need to bonus up the acid a little bit? Give me a little more power? No.
I'm thinking after like 5 years.
Yep, you would think so, but apparently the answer is no. I think if you abused your battery good, it might. If you ever went below the plates and you really pushed out some, that would be a potential, but you kind of lost right there. More questions?
Anytime you get below the top of the plate, you're losing capacity. It'll never be the same even if you have to.
Yeah. I've never found my batteries to that level, and that's horrifying to imagine. And they have a T105RE for renewable battery. So you know your normal battery is this tall, that one's this tall. They just gave you another 2 inches of water. Hey, that's a shock absorber for, what month did I check that? Get you a chart, that's how you know that. More questions on batteries? Okay, we talked a little bit about the 12.8 volts, the 13.6 volts. Okay, 12.8 is fully charged. 13.6 is about your absorbed voltage. The difference between those is 0.8 volts. A, that's not very much. B, you're going to be charging from your solar panels and sucking out from your inverter at the same time. This makes the voltage reading even less accurate. And it's only 0.8 between where you want to be and where you don't want to be. That's why a 48 volt system makes sense, because instead of 0.8 difference, 0.16, 3.2 volts difference. You see how that works? That gives you a much greater range. So your charge controller has a much greater chance of providing the energy that the battery is requiring in the form of voltage. You can use a hydrometer reading, whoever wants to get out the thing and test each cell. Now that's accurate. Charge, discharge, doesn't matter. That's accurate if you do it right. But there you are with your gloves and your goggles and your apron. And you don't want to get that on you, just saying. And you can measure the specific gravity. But if you're going to do that like every, like as your charger's going. So we use voltage to determine where the battery's at. So that's why the 48 volt system is desirable. In reality, I wish my system was 60 volts, because then it would provide even more, even smaller wire, even cooler components. But now we're starting to get to, can I get shocked? I'm guessing yes. You're starting to get, and on batteries, there's no fuse on a battery. You've got a battery, it's a power source. But between those two poles, yeah, it's a power plant. There's no fuse in there. So batteries are a force to be reckoned with, particularly when you get a battery bank. My battery bank holds 47 kilowatt hours worth of electricity. It could displace all of that in less than a second. That's a lightning bolt. I don't know how many people that would kill, but it would be a lot. That's an unimaginable sum of electricity. So you do have to realize that batteries, one battery is kind of a big deal. You can kind of weld with a 12 volt car battery. It's a little pathetic, but you can do her. But you sure can with more. So it's worth thinking about. Larger voltage means smaller wire, less voltage, and greater flexibility in the voltage. Another nasty. On a 12 volt power inverter that's rated for 2,000 watts, if you turn on something big like a well pump that's going to suck 1,800 watts, it's going to pull the battery voltage down so far, so fast that the inverter might turn on. Again, because you only have just a small range of what it says. Wait a minute, voltage too low. Because the inverter doesn't want it to go below like 11.5, not even for a second. So again, 48 volt, 24 volt, no problem. That's an example of like a 6-volt battery. Right there you can see it's got 3 cells, and it looks sealed, so it's AMG or gel. That's an AMG, Trojan, excellent name brand. I don't spend that money for Trojan, I get others. They're only really made by 3 companies. That one is really not made by Energizer. It's made by Deca or Penn in the United States. It is not a marine battery, because a marine battery is a piece of junk. Unless you're putting in a boat, then it's gonna work fine. A marine battery is a 12-volt deep cycle battery, but it's not, because it has thin plates, because it's not big. It's not deep cycle. It might be a little bit thicker than one in your car. Your car has really, really thin plates, and that's really great for sending a whole lot of electricity and then none. And it does pretty good at that. You can get 5-6 years out of it, even in northern Michigan. But a deep cycle battery works entirely different. That sends a more moderate amount of electricity for a huge amount of time. It's very different. The panels get sulfated. When they get charged and discharged, they get hot, sometimes flex. The smaller those plates are, the closer they are together, the better chance they touch one another, short out a cell, and now you don't have a battery anymore. And that's why I hate on marine batteries so much. My dad gets one for his little electric motor about every 2 years. Probably needs one every year. Depends how much he goes fishing. If he had two batteries, yeah, I know. 2 batteries, the problem exists. But he'd have 2 batteries. But this is a T105 class, essentially what I have. It's a 6-volt battery. There's no, that is not a deep cycle battery. That is a marine RV battery. That's what I like to have. Those are 2 volts. And that is my array, and you've got 32 T105s in rows, so like, sorry, the pointer doesn't work, but there's a bus bar right here, and there's a bus bar right here, and there's 8 batteries this way, and 8 batteries this way, and 8 batteries this way, and 8 batteries this way. In the winter it gets cold in that barn, so it has a little box that it goes in. In the summer the box comes off. The bus bar helps distribute the electricity evenly. I thought I could just use wires and jumpers, and no, you need to use a bus bar. Or you'll end up with a battery in the middle that doesn't get as much power, and then that's really an undesirable outcome. So a bus bar is not that big a deal, it's a hunk of copper. There's another view. As you can see, it's going to take a little while to go through there and top all those batteries. But it takes me about 20 minutes, and I have a system. And if you get a bunch of batteries, I'll be happy to show you. Right here, this is a flashed copper bus bar with solid fuses on each one. It's the best. Code did not require that. But as I looked at this and realized if you dropped a screwdriver on there, speaking of which, so there you are. Funny story. Go ahead.
So the ground is definitely not connected to earthquake.
In my case, DC, correct. Yeah. So there I am tightening up all those connections with my wrench, and I'm just going to be careful.
Big spark.
What do I do now? It's not on fire, I didn't die, it didn't blow up, but the wrench is there. I could leave it. What would happen? No, it's not a good idea. So I had to reach in and get it out of there. Now I had some stuff on when I did that. And after that, what you do is you take that wrench and you get yourself a little bit better electrical tape. And you wrap it top to bottom, and then you cut out the spots that need to be metal. And then that's the, and then you put it on a nail next to the battery bank. So it's always there and it's handy. So it's easier to use that than a pair of ice grips. That could have been a life-changing event. Hydrogen sulfide gas, really? I live. Anyway, I was lucky. Kind of see the diameter of the wire. This wire right here is 4-aught copper, goes to the inverter. That's pretty big. You don't want any, you want as little voltage drop as possible. Questions about the battery bank?
Hey, Chris?
Yes, sir.
I had an example where I had a new inverter system at the shop. And the shop was in Separate Lake. 12-volt batteries, 4 banks and 16 batteries in parallel. And this is why I like the way you set yours up, because if one of those batteries goes bad, it doesn't become the load. What happened was, just like you said, they sealed that acid batteries, charged controller, overcharged the battery, and the building smelled like rotten eggs. And what happened was, each one of those banks and 16 batteries in series, one of the batteries was born, became the load. So when I disconnected the 4 banks to shut off 48 volts, those batteries kept going. I had to go through every single battery and disconnect every jumper. And once I did that, we scrapped all 64 batteries, you know, how much money that was.
Ouch.
And then I disassembled the whole inverter, switched the generators over so that we could just run off the generators. And that was 2 banks of 64 batteries that we blew out going to set up to the junkyard.
Well, those fuses potentially would have prevented that. You could maybe put in breakers in there. One thing I would do if I was gonna do this again, and a guy told me about this, he said, well, I don't like putting all that crap inside the battery bank where the gas is. So I enclose it right there. So he put a board here or foam, ran the wires out and put the circuit attachments in the bar on the outside of the box with another enclosure.
So when the fuse opens, and it arcs, it's not gonna blow up the building.
That too. And you could put a breaker there and you could shut them off periodically to do load testing and stuff. So if I ever do it again, I'll isolate that. Also, any corrosion from the little bit of gas that does exist does populate on these terminals. It'd be nice to separate that. So, you know, live and learn. A couple things I do different. Look, we got a little ways to go yet. You guys want a break? I'm happy to do a break. Let's try to make her a 5-minute break though. Let's use the head, come back 5 minutes, and we'll get right back into it. Will that work?
Sure.
Okay, let's take 5 minutes.
Thank